oxygen, the life will not be on the earth, because we need oxygen to breathe in, to metabolize our food, and to generate energy. But same oxygen, if it is in trimolecular, triatomic form, is called ozone. And ozone is totally different from the oxygen. On one hand, oxygen is very essential for us. It is life-saving. But when we see the ozone, it has totally different property. It is highly reactive, and when we come in contact with this ozone, then it is damaging to us. It can damage our soft tissues, our respiratory tract, our eyes, and so on. So you can see that how the same oxygen, when it is present in combination of two atoms, it behaves in a different way. And if it is in combination of three atoms, it becomes ozone, and its behavior is totally different. And on one hand, we consider ozone as pollutant. On the other hand, we are trying to protect the ozone layer. So all depends where this ozone is present. So ozone present in the troposphere near Earth's surface is not good, is a pollutant, and we are trying to avoid it. On the other hand, the ozone which is present in the stratosphere is good for us, because it filters the ultraviolet radiations which are harmful for life. And you can see here the altitude, at what altitude. So most of the ozone in the stratosphere is found between 20 to 30 kilometers above the Earth's surface in the stratosphere layer. So I have already explained what is good and bad ozone, and also why it is bad and it is good. Yeah, here you can see that our sunlight consists of mainly three types of radiations: ultraviolet radiations, visible light, and infrared. And when light from sun comes to the earth, then most of the ultraviolet radiations are filtered by the ozone layer, which is blue layer in the stratosphere, and then very little ultraviolet radiation reaches to the Earth's surface. On the other hand, the visible light reaches to the Earth's surface, and due to this light, that all the life is flourishing. Photosynthesis is happening, and animals are getting food out of that. So if this light is blocked, that life will not exist on the earth. So we need some light, but this ultraviolet, we don't require so much. Ultraviolet radiations are also needed. For example, the synthesis of vitamin D in our body requires exposure to ultraviolet radiations, but not overexposure. Little ultraviolet exposure is required to synthesize vitamin D in our body. But lot of ultraviolet radiations, if it goes to the living body, then it causes different types of damages. There are three types of ultraviolet radiations based on their wavelength. So the longest wavelength ultraviolet radiations have been grouped as UVA, ultraviolet radiation A type. Then the shortest wavelength are referred to as ultraviolet radiation C, and then the wavelength which is in between, that is ultraviolet radiation B. So you can see here that due to ozone layer, all ultraviolet radiations C is stopped here by the ozone layer. So ultraviolet radiation C is high energy electromagnetic waves. So if they reach on the Earth's surface, they will damage life and different parts of our body. Ultraviolet radiation B is also stopped, but some amount of ultraviolet radiation B reaches on the Earth's surface, And most of the ultraviolet A is some amount is stopped by the ozone layer, but most reaches to the Earth's surface. Since ultraviolet radiation A is long, long wavelength radiations, so they are not very harmful. The most harmful is ultraviolet C type because it contains high energy and it has potential to damage our biomolecules, including the DNA. And that's why we are protected. If all ultraviolet C radiation reaches to Earth, then life will not be like what we have now. Plants will be different, animals will be different, including human beings, and probably we will be suffering from different types of diseases. As I said that ultraviolet UVA rays have longest wavelength, followed by UVB and UVC. UVC being the shortest in wavelength, they has highest energy. And that's why they have potential to damage our DNA molecules and cause different types of mutations and some diseases like cancer and other. You can see in this figure the penetration power of different types of ultraviolet radiations. Since on Earth we are exposed to only UVA and UVB, you can see that ultraviolet radiation A, which has longest wavelength, they can penetrate into our skin layer. Here, from here to here is the skin layer, not full, but they can go up to the middle. On the other hand, ultraviolet B, they can penetrate up to the surface or little below the skin layer. What happens if we are exposed or overexposed to ultraviolet radiations? Different types of diseases are caused, and the most serious disease is skin cancer. And these cancers can be of both the cancer of pigment cells, which are called melanoma, and in countries where skin is fair and they are exposed to more ultraviolet radiation, then they are suffering from skin cancers. And it is estimated that about 69,000 deaths happen throughout the globe by melanoma cancer. And about 350,000 people suffer from melanoma cancer throughout the world. So it's a large number. We are lucky and we have advantage that our skin is not as fair as Europeans or Americans. And that's why we are not at very high risk. But here also, if we expose for a long time, then such type of problems may arise. And it is present there, but not in as high frequency as it is found in European and other countries where people have fair skin. Then ultraviolet radiations, then we have non-melanoma cancers are also caused, which arise by basal cells of the skin or squamous cells of the skin. And from where they arise, they have been named as basal cell carcinoma or squamous cell carcinoma. So both types of which arise from pigment cells and other carcinoma which arise from basal cells or squamous cells. So all type of cancers can be formed by exposure to ultraviolet radiation. Then overexposure of ultraviolet radiation causes premature aging and skin damage. So if you are more exposed to the sun for a long time, then our skin gets damaged and appears as aged skin. Then large number of cataract cases are promoted by exposure to ultraviolet radiations. And this is also, cataract is also a cause of ultraviolet radiations. That's why we should protect. If we are going to strong sun, we should wear goggles so that ultraviolet radiation cannot strike our eyes and our eyes are protected. Then different types of other eyes problems are caused by ultraviolet radiation, and one is pterygium. Pterygium is tissue growth in the eyes, and if growth is more, then it blocks the vision, and that is also a common problem due to exposure to ultraviolet radiation. It is also known that little exposure to ultraviolet radiation is good because it helps in synthesis of vitamin D. But if our body is exposed for longer duration for in strong sunlight where more ultraviolet radiation is there, then it suppresses our immune system, and our immune system becomes weak, and we become prone to different types of diseases. Similar effect is also in other animals and plants, and that this way it harms our biodiversity, particularly marine life, and it also damages our crops, and collectively it affects our ecosystem. So ultraviolet radiations not only cause cancer and some other diseases, but collectively they affect our food production, our biodiversity, as well as our entire ecosystem. You can see in this figure, this dark spot on skin is a melanoma carcinoma, whereas such type of thing is a basal cell carcinoma, and here is a squamous cell carcinoma. And you might have seen that many people have such type of spots or small outgrowth on their skin, and that is mainly due to exposure to ultraviolet radiation. And these are actually benign type of cancer. And if the cancerous cell is spread to other parts of the body, then they cause other problems and death also. But in most of the cases, they remain like that for a long time, and they are benign. Then in 1920s, in United States of America, a group of chemicals were discovered known as chlorofluorocarbons or CFCs. So it includes different types of compounds. So CFCs are a group of chemicals, and similarly hydrochlorofluorocarbons were also discovered, and they found different uses due to their specific properties. So they were discovered in 20th century, early 20th century, in 1920s onwards, and both chlorofluorocarbons, CFCs and HCFCs, they are non-toxic. This is a good property. They are non-flammable, they don't catch fire, and then they are very stable. They don't degrade very easily. So it is good as well as bad also. I will explain how it is good. It is stable, so we can use this gas for a long time for different purposes. However, these properties of CFCs, these properties of CFC promoted them to use as refrigerant. So from 1920s onwards, we started using the CFCs and HCFCs as refrigerants in our refrigerator, freezers, and air conditioners. And we found that it is non-flammable, so even if there is leakage, there will not be fire in our house. It is very stable, so we can use for a long time, it will not degrade. And then it is non-toxic, so if there is leakage, it will not harm the human beings. That's why these gases were widely used as refrigerants in different types of equipment. And by early 1970s, we found that these gases found different types of uses, and total production reached about 1 million tons, means 10 lakh tons every year. And then other uses were also found of chlorofluorocarbons and HCFCs. They are used as aerosol propellant. They are used as solvents. In plastic industries, they are used as foam blowing agents, and they are also found in firefighting fluid, and they are also used in high voltage switch gear. And the use of CFCs in for all these purposes continued till 1990s, almost till 1990s. Later on, it was found that these chlorinated gases, CFCs and HCFCs, damage our ozone layer. And then different activities throughout the world started that how to protect or how to prevent the synthesis of manufacturing of these gases so that we can protect our ozone layer. And Montreal Protocol came into being in 1987. So before going further, there are several such type of chemicals which deplete our ozone. CFCs, chlorofluorocarbons, HCFCs, hydrochlorofluorocarbons, different types of halones where bromine is there, methyl bromide, carbon tetrachloride, methyl chloroform, chlorobromomethane, and then hydrobromofluorocarbons. So all these are used as refrigerant or some other uses, and all damage our ozone layer. And in short, we call it ODS, means ozone depleting substances. So as I said, that ozone depleting substances are very stable, and they are not degraded for a long time when they are released. Here in this table, you can see that some CFCs, they can persist for 45 years, 100 years, 85 years, 300 years, even 1700 years in our atmosphere. So once they are released, they are not degraded and they persist in our environment or atmosphere. So for environment, they are not, its stability is not good because they are not degraded. So that's why whatever we release every year, they are accumulating in our atmosphere. So then another problem with these gases are they all have global warming potential, and some have as high as 1000 times more global warming potential compared to carbon dioxide. And so this way, these gases are not damaging only our ozone layer, but they are also greenhouse gases, and they are contributing towards global warming and climate change. You can see here in this slide that how chlorofluorocarbon, CFCs, deplete or damage our ozone layer. So when CFCs, as long as they are in troposphere, they are very stable because they don't get high energy radiations to break. But when they reach to stratosphere, where where ultraviolet radiations are more, then CFCs in presence of ultraviolet radiations are split into chlorine radicals and CFCl2. And this chlorine radical is highly reactive, and when it combines with ozone, so it forms ClO, chlorine monoxide, and then molecular oxygen. And this way, it damages the ozone present in stratosphere. Many other factors also contribute. This chemical reaction is not as simple as I have explained. The cold temperature and then polar vortex and then stratospheric clouds, all these also play important role in depletion of ozone layer. Not only that, when Cl radicals combine with ozone, they form chlorine monoxide and oxygen molecule. This chlorine monoxide again attacks ozone molecule, and then ozone molecule is broken down into molecular oxygen and chlorine radical. And again, this chlorine radical takes part in breaking down of ozone. So a cycle goes on, means same chlorine radical participates several times to break the ozone layer. And that's why it is called chlorine catalytic cycle. So it's not that one molecule of CFC only breaks one molecule of ozone. The constituents of CFC's chlorine radical and ClO participate 100 times or even more to break the ozone layer. So that's why the depletion of ozone layer is very fast if CFCs and other ozone depleting substances reach to the stratosphere. As I said, that many other factors like polar stratospheric clouds and polar vortex, these are the atmospheric phenomena. I will not go into much detail, but just I want to say that polar stratospheric clouds are clouds formed in stratosphere. So most of the clouds near the Earth's surface are present in troposphere, but sometimes in very cold weather, vortex. Polar vortex is a low pressure areas in the event of very cold temperature, and this also plays important role in depletion of ozone as well as formation of ozone. So both play very important role, and polar stratospheric clouds are generally formed when temperature is minus 78 degrees Celsius. So it happens only in winter when temperature goes down so much, and then when temperature rises, then depletion of ozone happens due to these two factors. You can see here that up to 1980, the ozone was quite good in our stratosphere. The concentration was good. And then after that, slowly, it started declining. So you can see in 1986, 1990, 1995, up to 2000, there was a steady decline in ozone layer, ozone concentration in our ozone layer. And still decline is going on. And the first time when we realized it was in 1980s, scientists found that there is depletion of ozone layer. And first time a photograph was captured, or image was captured in October 1983 of ozone hole. So ozone hole is not any hole or anything, but it is the area of ozone layer where ozone concentration is very, very low. That's why that area contains a very thin layer of ozone. That's why it is called ozone hole. So first time ozone hole, this dark brown area, was demonstrated to the people, to the scientific community in 84, because this work was published it was reported in 84 and it was published in 95 by Bhartiya et al. And then it was clear that there is formation of ozone layer by depletion of ozone molecules. Yeah, so in the process of protection of ozone layer, many studies played important role. Though ozone was discovered in early 19th century, in around 1830, but it was 1865 where Soret proved that ozone is nothing but is triatomic molecule of oxygen, that is O3. In 1879, Cornu measured the solar spectrum and found that a sharp decline is of ultraviolet radiation when it passes through the ozone. So it means ultraviolet radiations are filtered by the ozone. The next discovery was by Cabanis and Dufay, who reported that ozone layer is present about 10 miles above the Earth's surface, means around 15 kilometers above the Earth's surface. And first time this ozone layer was reported in 1925 by Cabanis and Dufay. Then in 1973, James Lovelock detects chlorofluorocarbon CFCs in atmosphere. And thereafter, Roland and Molina, they found that CFC is playing harmful role in depleting ozone. And considering all these findings, in order to save ozone layer, the first international conference meeting was held in Washington in 1977 under the aegis of United Nations Environment Program, and in order to discuss that how we can reduce the production of CFCs and how we can save our ozone layer in a stratosphere. In 1982, Chubachi reported how low ozone is over Antarctica. And in 1985, 84 ozone hole was discovered over Antarctica, as I explained earlier. And then in 1985, Vienna Convention was called, a conference in order to save ozone layer. But the major thing was done in 1987 when Montreal Protocol was signed in the city of Montreal, and that's why it is called Montreal Protocol. And the main objective was to check the production of CFCs or other ozone depleting substances and to save our ozone layer. In 1990, a multilateral fund was created under the Montreal Protocol because in order to stop production of CFCs in developing countries, developing countries needed some financial assistance. So through this multilateral funding was provided to developing countries or poor countries to stop production of CFCs and switch over to new products, new compounds which are not harmful for the ozone layer. It was in 1992, India signed Montreal Protocol, and by 2010, all production of CFCs have been stopped. So if any production is happening, that is happening in a clandestine manner, not openly, but officially all CFC production has been stopped, and it happened by 2010. And under Montreal Protocol, we are expecting that production of HCFCs will also stop by 2030, because both the gases, CFCs and HCFCs, are ozone depleting substances. So we have targeted to stop the production of these two and some other ozone depleting substances by 2030 and some by 2040. So Montreal Protocol was signed in 1987, and Montreal Protocol targeted 96 chemical compounds which are used for 240 in 240 industrial sectors. And these compounds were either ozone depleting or they have greenhouse potential, means causing global warming and climate change. So Montreal Protocol decided to phase down the consumption as well as production of different types of ozone depleting substances stepwise, because if you stop suddenly, then it will affect the economy and production of different types of equipment. So stepwise stoppage of production was proposed. And as I have said, that by 2030, HCFC will also be stopped. And this way we are able to reduce the production of ozone depleting substance almost 99%. only 1 to 2% are still being synthesized, which is damaging our ozone layer. Otherwise, 98 to 99% production of such type of substances has been reduced and no production is taking place. Montreal Protocol is considered a very successful protocol. The reason, and it is also called Universal Protocol. The reason is by 2013, around 197 countries of the world signed this protocol, means they agreed to act on the guidelines of the protocol to reduce CFCs and other ozone depleting substances. And you can see the countries marked with blue color are the signatories of Montreal Protocol. It means entire globe has agreed to abide by the Montreal Protocol. And what happened after that? You can see the production of ozone depleting substances in this graph. There was a time around 1988-89 when production of ozone depleting substance reached almost 1.5 million, means 15 lakh ton per annum. But after the signing of Montreal Protocol and taking necessary measures by different countries, the production started declining. And you can see here graph is up to 2014, but it has declined drastically. Even here in this graph, CFC 11 since 1990, how it has declined drastically due to Montreal Protocol. Not only CFC and HCFC, all other ozone depleting compounds like CFC, carbon tetrachloride, halones, methyl chloroform, HCFCs, methyl bromide, and other CFCs all declined after 1990, and production came down drastically. Not only production, even consumption of these compounds also came down, and you can see that blue color is CFC. It was stopped in 2010, so there is no production, no consumption, and little bit other like HCFC is going on, and we have targeted to phase out it by 2030. So there is no consumption also due to Montreal Protocol. We have discovered substitutes of these compounds because we need refrigerants. So several other chemicals have been discovered which are less harmful to the ozone layer, and those chemical compounds are being used. So due to Montreal Protocol, not only production and consumption of ozone depleting substances declined, but we have noticed the improvement in ozone layer. So healing of ozone layer have also started, and slowly there is improvement. And sudden improvement we saw in 2019, where we found ozone hole very small. And we were very excited that it happened probably due to lockdown when pollutants were not produced, but the reason was different, which I will explain later on. However, the ozone hole in 2020 expanded due to powerful, steady, and frigid polar vortex, as well as cold stratospheric temperature. So it was not due to lockdown, but it reduced. But in 2020, again, the ozone hole became bigger due to very cold temperature and some other atmospheric phenomena. So it is expected that by complete adoption of Montreal Protocol, it will protect about 280 million cases of cancer. We can reduce 280 million cases of skin cancer and about 1.6 million deaths due to such type of cancers. So it is also going to help. It will not promote formation of cataract in our eyes. So this way also it will be helpful. Then Montreal Protocol facilitated the healing of ozone layer. And as it is expected that since these compounds, CFCs and other ozone depleting substances, though they have been completely stopped, Their production has been completely stopped, but still they persist in our environment because they are very stable. So immediately layer is not going to be improved as it was before 1980. It will take about 50, 60 years, and probably by 2050 and 2060, the ozone layer will be normal. Montreal Protocol has also helped in reducing the global warming and climate change. Reason is all the ozone depleting substances or gases are greenhouse gases. So if we stop production of these gases, then we can reduce global warming and we can slow down the climate change. So Montreal Protocol has not only helped in healing the ozone layer, but it also has helped in reducing the global warming and slowing down the climate change. And you can see here how the concentration of ozone in stratosphere was the depletion was increasing in after 79, 80 due to CFC, and then it started declining. So depletion has declined slowly, but it has not gone to original position. And you can see in these pictures here that up to 1971, there was no sign of ozone depletion. This blue color shows the ozone depletion. So you can see in these photographs, figures, that 71, 72, 79, there was no sign of ozone depletion, but in 84, we saw the ozone hole, and which increasing year after year. And it was in 2019, we saw a very small ozone hole, and we thought that it is due to lockdown, but it was not due to lockdown, because suddenly next year, again, hole became bigger. In these pictures, you can see how in 1979, ozone hole was very small, which started increasing slowly, and then still increasing. And it was in 2019, the ozone hole became smaller. But in 2021, again, it is increasing due to climatic phenomena. And but overall, at micro level, if we see, there is little improvement in the ozone layer. So Montreal Protocol is not a static protocol that once it is signed and after that whatever guidelines are there, people have to follow. It is monitored, and then improvement is taking place by adding different amendments. So Montreal Protocol was signed in 87, and then it was amended in London in 1990, then Copenhagen in 1992, Vienna in 1995, then again in Montreal in 1997, Beijing in 1999, and then we in Kigali in 2016. And in every such amendments, we are adding more chemicals which are ozone depleting to phase out and to stop the production. Imagine if there is no Montreal Protocol. So the depletion of ozone layer might have taken like this. But after Montreal Protocol, ozone layer depletion declined a little bit. After London amendment, again declined. Similarly, after Copenhagen, Beijing, Montreal, and then Kigali, it's declining and declining. So it is not a static protocol. Scientists are actively engaged to do more and more and bring amendments so that we can reduce the depletion of ozone layer. And in Kigali, in 2016, it was targeted that HFCs, hydrofluorocarbons, which is not a ozone depleting substance, but it is a global greenhouse gas. So it was also proposed that by 2040, HCFCs should also be stopped, its production should also be stopped, so that side by side, we can also save our Earth from the climate change, global warming and climate change. But this is not enough. More to be done to save our ozone layer as well as to save our Earth from the global warming. So the Montreal Protocol has achieved remarkable success, but more has to be done. A major gap in this strategy is substantial emission leaks from the old air conditioners, refrigerators, and insulating foams. So the equipment which were made long back and now they are getting old and discarded. So these compounds are still there, and how to retrieve those ozone depleting chemicals from those old equipments, that is a challenge, and we have to take some action from that in this regard. The Montreal Protocol also does not consider ODS used as feedstock. What happens that the ODS, ozone depleting substance, which is used as refrigerant, we have targeted. But in many chemical industry, CFCs or ozone depleting substances are used as raw material to produce some new chemical. So ozone protocol has not targeted those raw material which are actually ozone depleting. Then another problem we learned, that is the emission of nitrous oxide, N2O, which are being emitted by burning of fossil fuel, by industrial processes. And N2O, nitrous oxide, is also a ozone depleting substance and is a big challenge how to control the emission of nitrous oxide. Otherwise, it will also contribute to the depletion of ozone layer. So there is need for reducing as quickly as possible, not only the original targeted Montreal Protocol gases like CFCs, HTFCs, SCFCs, but some more gases like nitrous oxide and other ozone depleting gases, so that we can save our ozone layer. As I said, that production of HFCs, which is a global greenhouse gas, is still increasing, and by 2040 we have targeted to stop the production of this. And HFCs have global warming potential as high as 1,400 to 5,000 times more than the carbon dioxide. So even they are synthesized in a small amount, they can cause global warming and climate change. And this HFC has been targeted to be phased out by 2040. And if Montreal Protocol is functioning well, then it is expected that the ozone hole will reach to before 1980 condition by 1960 or 1965. But if some more compounds are found that they are ozone depleting, then probably we will not be able to fulfill this target. But scientists, different governments are working in this field, and probably let's be optimistic that by 2060 or 2065, our ozone layer will be normal. It will be as good as before 1980s. So as an individual, what we can do, means the government and group of scientists, they are making policies, but there is responsibility from our side, what we can do. So use refrigerators, air conditioners, and other equipments responsibly. It's not that buy more and more equipment unnecessary. We should use these equipments in a responsible manner, and then buy air conditioner and refrigerators which do not use ozone depleting substances. So we should see the levels. If those equipments don't use such type of chemicals, then we should buy. Conduct regular inspection and maintenance of air conditioning and refrigeration appliances to prevent and minimize refrigerant leakage. So we should maintain and look after that any leakage is happening or not, particularly with the old equipments, so that we don't allow these gases to go into the atmosphere. For existing air conditioning and refrigeration appliances that operate on HCFC and CFCs, when they are discarded, then we should try to discard at some facilities where these ozone depleting substances can be recycled. Otherwise, they will go into the atmosphere and increase the level of these ozone depleting substances. And then we know that some ozone depleting substances are also used in different cosmetic products, hairspray, room fresheners, cleaning products. So we should look after that. If we are buying some such type of products, there should not be such type of chemicals which are ozone depleting. And then it is our responsibility to create awareness and educate people so that they take all these measures and we can reduce the production of ozone depleting substances and we can save the ozone layer. Yeah, so thank you very much. And if any questions are there, I will be happy to discuss. And if there are no questions, it's okay.
Thank you, sir, for your detailed, deliberate, and elaborate lecture given to us. So now I request Professor Asagupta, Chairperson of Sheet and Sakti Manipur, to moderate today's webinar and give the presidential address. So, Madam Asagupta, please.
So I request if there are any questions to Honorable Speaker, please ask. The session is open for discussion. So if you have any queries, please do ask to our respected speaker.
Sir, I have a simple question.
Okay.
So about the ozone hole, we are mainly considered that hole at the Antarctic region. So
Yeah.
is there any different views about the North Pole region? Because at the polar region, this thing ozone layer is quite thin than that of the equatorial region. So any report from the North Pole, sir?
Yeah, it's a very good question. Means the Antarctica region is very cold compared to Arctic. So ozone hole was means observed in Antarctica. But 2 years ago, the ozone layer got thinned in Arctic region also, but that was due to some climatic abnormality. So, and a recent study, they reported that there is depletion in other parts of the globe also. But then a lot of questions were raised on that. And scientists suggested that more studies should be done to conclude that ozone depletion is happening at other regions of the earth. So far we are confirmed that ozone layer has depleted in the Antarctica, and sometimes it is happening on Arctic also, North Pole. But other region, people have reported here and there, but we cannot say in a confirmed way that depletion is happening in other regions of the globe also. Okay?
Thank you, sir. Thank you, sir. It's quite clear.
Please ask if you have other person's query. Hari Priya is there, others are there. Any query, please ask. These are rare chances. You are all teachers. If there is some problem, some question, please do ask our respected speaker. Well, if there are no queries, let me sum up and say a few words. Respected chief guest and resource person of today's webinar, Professor Singh from NEHU, our Shakti and Seed members. We have some representatives from some delegates from outside Manipur. Professor Vidyanath Jha was there, others I could say. So all the delegates, respected delegates from different colleges and universities. It's really a great day that we got a very, what to say, an academician with us who is with us to deliberate on the topic, which is very important and crucial, that what is the status, how the things have happened, what is happening at present, and whether there are other ozone depleting substances which are to be taken care of, and what will happen. So all these things professor has deliberated very well. He started with ozone structure, then he talked that how it is present in stratosphere, very less amount in troposphere. He talked about concentration in these two places, troposphere and stratosphere. Then he talked about good and bad type of ozone and why it is so, why we call good ozone or bad ozone. Then he talked about the UV radiations, A, B, C types, their wavelengths, and how which is more harmful. He talked about the health problems which we are facing because of the exposure to ultraviolet radiations if the ozone hole is depleted or if it is thinner. He talked about different ozone depleting substances like chlorofluorocarbons, hydrochlorofluorocarbons, and other ozone depleting substances, how they are causing ozone depletion. He talked about polar stratospheric clouds. He talked about polar vortex. He talked about concentration of ozone, how it was and how it has been changing through all these years. He said that first it was observed in 1983, then 84 it was noted, and 85 it was published. So we generally see in literature that in 1985 the ozone hole was discovered, it was known. But as Sir has said, that it was pointed out already in 1983, studied, and then in 84 it was sent, 85 it was published. Then he has given a very beautifully, he has given the timeline for various conventions, protocol, starting with the this Vienna Convention, then how it has led to Montreal Protocol, and coming up to Kigali 2016 in Rwanda, which has taken place, and how and why, how it was discovered, how was the process, how it was measured, at what altitude it was present, like that. I mean, different timelines for all the progress which has happened in the history of this ozone discovery, then ozone depletion, and what is the progress taking place in that way at a global level. He talked about global emission of these ozone depleting substances. Then a lot he talked about Montreal Protocol, that its success story. Then he talked about the production and consumption scenario of these ozone depleting substances. Then the substitutes are there and they have to be used. They are less harmful, of course. There are a lot of substitutes and alternatives which have come up. But he has pointed out us about the nitrous oxide, which is there, and then in what way in what way it can be reduced, need to reduce it. He talked that it is hoped that by 2065, if all phasing out of hydrochlorofluorocarbons, which are used as substitute, whose potential for diminishing ozone was little lesser, so they were given later, I mean they came later in the stage for phasing out scenario. So he has given the evidence and hope that by 2060-65 it is believed that it will be in its precondition. What is needed is the awareness on the subject, because it is the daily use chemicals and substances which we are using and which are responsible for giving the depleting substances which are responsible for depleting ozone. So in what way we have to take care of our refrigerants, aerosols, and fumigants, etc., that he has talked about, and how the awareness on the subject is very important. Thank you, sir, so much for deliberating upon all these issues in a very detailed manner. We are really thankful from Seed and Shakti from the core of heart and on my own behalf that you have accepted our invitation just at one phone call, and then you are here and presented so beautifully on the deliberated on the subject. And when we are talking of awareness, that is why this webinar is there. Now, sir has touched all the points, so that is why I think nothing is left which I have to talk. But still, just as a because here the theme of this 2022 is Montreal Protocol at 35, global cooperation for protecting life on Earth. So that is why I will be talking about how this cooperation it has led to this. Other details about ozone, ozone depleting substances, their phasing out, and various convention protocols are up to Kigali sir has already talked. So you see why we are celebrating these international days. We are celebrating these international days just to educate the public on these issues of concern, just to mobilize the political will and also resources to address the global problems, and also to reinforce, to celebrate achievements which is there for humanity. We know that the adoption of Montreal Protocol, it was there for substances that deplete ozone layer. It took place on September 16, 1987, and it was a turning point in the environmental history because what it showed, it shows that how science and political willpower, when they join, then the results can change the world. So Montreal Protocol, therefore, it is considered as the best example of the positive and powerful outcome of multilateralism. And this is expressed by UNEP Secretary, Executive Secretary, that when sound science is the basis, he says, when sound science is the basis for universal action, we can overcome what may seem very difficult, insurmountable global environmental challenges or problems. As sir has already pointed out that in 1970, mid-1970s, scientists already warned that there are man-made chemicals in everyday products which we are using like aerosols, foams, refrigerator, air conditioner, which are harming the ozone layer. But at that time, nobody imagined what may be the scale of this problem. But in 1985, as sir said, in 1983 it was discovered. However, in 1985 it was published that a hole was confirmed in the ozone layer over Antarctica. So this sun shield, words very important sun shield, it was breached, which is protecting man, animals, plants, crops, and ecosystems from excessive ultraviolet radiations. So suddenly danger loomed over the future. There may be skin cancer, there may be cataract, there may be dying plants and crops, there may be damaged ecosystems, and so on and so forth. But there was no time to lose. And the world has acted, and the global leaders also they acted immediately, urgently, and listened to scientists because scientists raised the alarm and the whole world listened to them. And therefore, when in 1985 it was discovered, in 1985, government adopted Vienna Convention. At that time, 28 countries were there who ratified this convention for the protection of ozone layer. And this 1985 Vienna Convention, it paved the way for Montreal Protocol, which was there launched in 1987 to phase out the ozone depleting substances, including chlorofluorocarbons. This protocol, it became effective in 1989. And as sir has also pointed out, it is the only example in UN history that which is universally ratified by every country in the world. You have seen blue picture in the map. All countries they have ratified. In 2008, it is the first and only UN convention which is accepted. So this is the glaring example that when there is sound basis of science and the political will of global leaders, then the wonders may happen. Here, United Nations Environment Program, it played a key role. And in Vienna Convention, it brokered the Vienna Convention and it started Ozone Secretariat in Nairobi, Kenya, which was hosted by UNEP and it works since 1991. 94, they thought that it is to be proclaimed that 16 September, on which the Montreal Protocol was launched, that it should be the International Day for Protection Preservation of Ozone Layer, commemorating the day of signing of 1987 Montreal Protocol. That all of you know. And now this treaty, it turns out 35 years has happened to it. And we remember that how this Montreal Protocol, it has helped in ending one of the greatest threat which the humanity was facing, as a whole, and which would have come if the depletion of ozone layer would continue to take place. So in this way, it is a great success, and it shows that how multiple nations, many nations, multilateralism, multiple dimensions to it, which has added effective global cooperation, how it has worked well. It is a shining example, and how it has helped in phasing out these gases. So, we know Sir has talked about halocarbons, with ozone depleting potential. He has talked about methyl bromide, methyl chloroform, carbon tetrachloride, families of chemicals known as halones, chlorofluorocarbons, and hydrochlorofluorocarbons. About 100 chemicals are to be controlled, and then they are taken care of. So the important thing is that this treaty has set out a timetable for phasing out the production and consumption of these substances, and aim is to eliminate them completely. However, there are few exceptions to it. For example, there is no alternative or no substitute, and which are very essential to use in some cases. For example, in case of asthma or respiratory diseases to treat with, the meter dose inhalers MDI are used. There are no substitute to it, so they are used. Similarly, halon fire suppression system, which are used in submarine and aircraft, that is still continued. Now, when we say that all phase out schedules in as expressed in Montreal Protocol, they went on very well. And initially, you see how they have worked. Initially, they focus attention on those chemicals which are having high ozone depleting potential, and it included CFCs and halones. Then the SCFCs were taken. They were relaxed because they have got lower ozone depleting potential, and because they are they also have been used as transitional substitutes for CFCs. So it is believed that the final phase out for that is 2030 for developed country and 2040 for developing countries. And in 2007, parties to Montreal Protocol decided to accelerate the SCFC phase-out schedule for both developed as well as developing countries. So, in this way, we understand that how Montreal Protocol, it has acted in helping in saving the humanity from a great threat of ozone depletion. Then the Kigali Amendment took place in 2016 in Kigali, Rwanda on 15th October, and it was to phase out for 100 years in future. So what we have to say, that Montreal Protocol is a glaring example, is a shining example that governments and dedicated individuals can continue to protect the global environment, and it is a global agreement. Montreal Protocol is a global agreement to protect ozone layer, and it is one of the most successful environmental agreements to date. So what is needed for us, sir has already said in the last slide that what we can do as an individuals. So we should take up efforts. We are here Shakti and Seed members. We should take up collective efforts, strengthen them, and spread awareness on preserving the ozone layer. I am thankful to sir again for his deliberations and wide coverage of the topic. on various aspects. Sir, again, thank you from.
Thank you, madam. It was pleasure for me to interact with the two societies which are doing very nice work.
Thank you,
Thank
sir.
you very
Thank
much.
you so much. Then I'm thankful also. There will be formal vote of thanks, but let me thank Dr. Ibe Chaubi, who has taken initiative, Dr. Binita and Dr. Daisy, doctors and Santosh Nahakpam, without whose help we could not have this online webinar. And then all members of Seed Shakti and delegates who are here to listen to our honorable speaker. So with this, I hand over this to Surukhaibam Ebichaubi Devi.
Thank you, madam, for nice submission and supplement to our resource person. Thank you, madam, once again. So now I request Dr. Daisy Angom, Assistant Professor, Thawal College, to deliver the vote of thanks.
Yes, thank you, Vichawi. Am I audible?
Yes.
Yes, sir.
Okay, good evening, all. I feel honored and privileged to get this opportunity to propose vote of thanks on this special webinar in relation to the observation of World Ozone Day with the motive to protect and conserve this unique layer. As we all know, the focal theme of this year's celebration is global cooperation, protecting life on Earth, which focuses on joining science and political willpower as the result can change the world. I, on behalf of the organizing committee, convey my deep regards and hearty thanks to our honorable chief guest and resource person of today's webinar, Professor Om Prakash Singh of the Department of Environmental Science, Northeastern Hill University, Shillong, Meghalaya, for taking out time from his busy schedule to give us a very interesting presentation on the topic entitled Healing of the Ozone Layer, the Montreal Protocol and Beyond. Thank you, sir, for your valuable speech. In your speech, sir, you have very clearly explained the origin of the issue, that is the issue of the ozone depletion, the various important factors like polar stratospheric clouds, polar vortex, etc., which are influencing the depletion of the ozone layer, besides the main culprits like the chlorofluorocarbons, halogens, hydrochlorofluorocarbons, etc. You have also graphically demonstrated the increase in the ultraviolet rays or the increase in the ozone depletion or the penetration of the UV rays since graphically since 1980, I think, and beyond. You have very nicely shown in a graphical way. Thank you, sir, for your valuable presentation.
Thank you.
My sincere thanks is also due to Dr. Asa Gupta, retired Professor, Manipur University, President, Seed and Sakti Manipur, for the lively, informative and suggestive moderation as well as for the compact presidential speech. Thank you, Madam. I also extend my sincere thanks to Dr. K. Binita Devi for introducing our resource person, Professor Om Prakash Singh, enlightening us about the varied activities and interests of our speaker. Thank you, Madam. Heartfelt thanks is also due to Dr. Ibichawi for the warm welcome and also for your painstaking efforts in organizing and hosting this webinar to make this webinar a grand success. I would also like to express my sincere gratitude to all the esteemed delegates of this webinar for their presence and contribution in making this webinar a grand success. Thank you to all the delegates from inside and outside our state. Lastly, but not the least, I extend my heartfelt thanks to Santosh Nahakpam, Program Officer for the electronic coverage, and also to all the members of SEED and Sakti Manipur for making this webinar a grand success. I once again thank you. With this, I conclude my thanks. Thank you, everybody.
Thank you, Daisy, for your nice word of thanks. And thank you all. And I request all the participants to fill the feedback form that is available in the chat box. So, ma'am, I think we should close. So, with the
Yeah.
permission, is there anything left? So, with permission from the chair, our today's webinar is closed.
Thank you.
Thank you, sir. Thank you so much.